Hello everyone, welcome back to my YouTube channel. In this video, I'm discussing about ANOVA, that is analysis of variance. Now let's get into the topic. And before that, I'm discussing about the introduction of ANOVA, F statistics, technique of analyzing variance, and classifications of analysis of variance, that is one-way and two-way classification, and the last applications of analysis of variance. The analysis of variance is developed by R.A. Fisher in 1920. If the number of samples is more than 2, the z-test and the t-test cannot be used. The technique of variance analysis developed by Fisher is very useful in such cases, and with its help, it is possible to study the significance of the difference of the mean values of a large number of samples at the same time. The techniques of variance analysis originated in agriculture research, where the effect of various types of soils on the output or the effect of different types of fertilizers on production had to be studied. The technique of the analysis of variance was extremely useful in all types of researches. The variance analysis studied the significance of the difference in means by analyzing variance. The variances would differ only when the means are significantly different. The technique of the analysis of variance as developed by Fisher is capable of fruitful application in the variety of problems. H naught, H0 or HO variability of W bar I groups is equal to variability of B bar T groups. This means that H1 is equal to Hn. HA variability of a W bar I groups does not equal to variability between the groups, or H1 is not equal to Hn. F statistics. ANOVA measures two sources of variations in the data and compares their relative sizes. Variation between the groups and variation within the groups. For each data value, look at the difference between its group mean and the overall mean, that is which between the variance groups. When it comes to within the groups, for each data value, we'll look at the difference between the value and the mean of its groups. The ANOVA F statistics is the ratio of the between the group variation divided by the within the group variation. That is, F is equal to variance between the and the variance within the group. The large F is evidence against H is 0, since that indicates that there is more difference between the groups than within the groups. The technique of analyzing variance. The technique of analyzing the variance in case of a single variable and in case of two variables is similar. In both cases, a comparison is made between the variance of sample means with the residual variance. However, in case of a single variable, the total variance is divided in two parts only. The variance between the samples and the variance within the samples. The latter variance is the residual variance. In the case of two variables, the total variance is divided in three parts, that is, variance due to a variable number 1 and the variance due to a variable number 2 and the residual variance. When it comes to classification of ANOVA, the analysis of variance is classified into two ways, that is, one-way classification and the two-way classification. One-way classification. In one-way classification, we take into account only a one variable, say the effect of different types of fertilizers on yield. Other factors like difference in soil fertility or the availability of irrigation facilities, etc. are not considered. For one-way classification, we may conduct the experiment through a number of sample study. Thus, if four different fertilizers are being studied, we may have four samples of say 10 fields each and conduct the experiments. We will note down the yield on each one of the field of variance samples, and then with the help of the F-test try to find out if there is a significant difference in the mean yields given by the different fertilizers. You can see from the table the replicants is 1, 2, 3, the total will be, and what are the values we have given for The first one is, yeah, we will start the null hypothesis. Null hypothesis, that is the mean yield of the four fertilizers is not different in the universe, or H0 is equal H0 is tends to mu1 is equal to mu2 is equal to mu3 is equal to mu4. The alternate hypothesis will be H0, the mu1 is not equal to mu2, and the mu2 is not equal to mu3, and the mu3 is not equal to mu4. That is mean. The next is the compute grand total, that is G is equal to summation of XC1 plus summation of XC2 plus summation of XC3. That is the correction factor, that is CF. The C to find this CF, that is a G square divided by N. And the next is the total sum of samples, that is SST, which is called as a total sum of samples. SST will be equal to summation of C1 square plus summation of C2 square plus summation of X3 square minus correction factor, that is G square divided by N. The next one is sum of squares between the samples, that is from the columns SSC is equal to B minus SSC is equal to summation of C1 square divided by NC1 plus summation of XC2 whole square divided by NC2, and so on, and minus uh, correction factor, that is CF, where NC1 will be the number of elements in first column, etc. The next is sum of squares within the sample, that is SSC. The SSC will be equal to SST minus SSC. SST means the total sum of samples, and the SSC will be a sum of the squares between the samples. The next one is the number of different degree of factor for between the samples will be V1 is equal to C minus 1, and the number of degree of factor for within the samples will be V2 is equal to N minus C. Mean squares between the columns is MSC, that is SSC divided by C minus 1, and the SSC will be to find SSC, that is the MSC will be equal to SSC divided by M minus C. The mean squares within the samples will MSC is equal to SSC divided by N minus C. The last F ratio, the F ratio will be MSC divided by MSC divided by MSE if MSC will be greater than MSC, or MSC divided by MSC if MSE is greater than MSC. We can see from the table between the this is the ANOVA table for one-way classification. Source of variance, which includes between the samples, that is the column between the samples would be considered as columns, within samples, that is residual, and the total. The sum of squares SSC, SST. The mean sum of squares is MSC and MSC. The ratio will be F is equal to MSC divided by MSC divided by MSE. When it comes to a two-way classification, in a one-way classification, we take into account the effect of only a one variable, that is columns. If there is the two-way classification, the effect of two variables can be studied, that is columns and the rows. The procedures of analysis in a two-way classification is in total both the columns and the rows. The effect of one factor is studied through the columns-wise figures, and the totals and the others through the row-wise figures and the totals. The variance are calculated for both the columns and the rows, and they are compared with the residual variance or the error. The first point will be, we will start the null hypothesis, that is the mean yield of the four fields is not different in the universe, or the H0 will be mu1 is equal to mu2 is equal to mu3 is equal to mu4. The alternate hypothesis will be mu1 is not equal to mu2, and mu2 is not equal to mu3, and mu3 is not equal to mu4. That is mean values. And compute grand total, that will be G is equal to summation of all XC1 plus XC2 plus X3 that is summation, and the correction factor, that is CF value, will be equal to G square divided by N, that grand total square whole square divided by N. The next is total sum of samples. That is SST, same as one-way classification. That is SST will be equal to summation of XC1 square plus X summation of XC2 square plus a summation of X3 square minus G square by N, that is correction factor. The next one is sum of squares between the samples, that is we consider for columns. First one is columns. SSC will be for columns. That is the summation of all XC1 square X divided by NC1 plus summation of XC2 square divided by NC2 and plus summation of XC3 square divided by NC3 minus correction factor, where NC1 will be a number of elements in first column, etc. The next point is the sum of the squares between the rows, that is SSR, that is a summation of XC1 square R1 square plus divided by NR1 plus summation of XR2 square divided by NR2 plus summation of XR3 square divided by NR3 minus correction factor. NR1 will be number of elements in first row. SSR is equal to C minus D. The next is sum of the squares within the samples is SSE will be equal to SST minus the total sum of SSE plus SSR. The next is the number of degree of factor for between the samples is C minus 1, and the number of degree of factor for between the rows will be R minus 1. The mean squares between the columns is MSC, and the mean squares between the rows is MSR. The MSR will be equal to SSR divided by R minus 1, and MSC will be equal to SSC minus C minus 1. And the mean squares within the samples is MSC equal to SSC divided by C minus 1 and R minus 1. Between the columns will be the F ratio will be MSC divided by MSE. For between the rows will be F is equal to MSR divided by MSE. We can see from the ANOVA table for the two-way classification, source of variance will be between the samples, between the replicants. The samples will be for columns and the replicants will be for rows. Within the samples will be a residual and the total. Sum of squares, mean sum of squares, and the F ratio. When it comes to applications of ANOVA, we can similar to a t-test, more versatile than a t-test. ANOVA is a synthesis of several ideas and it is used for multiple purposes. The statistical analysis depends on the design, and the discussion of ANOVA therefore includes common statistical design used in the pharmaceutical research. This is particularly applicable to experiment otherwise the difficult to implement, such as in the in the clinical trials. In the bioequivalence studies, the similarities between the samples will be analyzed with ANOVA only. That means we can analyze our drug is showing a significant pharmacological action or not. And when it comes to general applications, we can use in pharmacy, biology, microbiology, agriculture, statistics, marketing, business research, finance, mechanical calculations, etc. Thank you.